Okay, TypeScript. So on Tuesday it was an introduction to object-oriented programming, which is a really important concept to be aware of. But you're primarily learning JavaScript. JavaScript doesn't really work nicely with object-oriented programming. It's not an OO language. So certain languages you must follow OO principles for kind of everything. JavaScript it's not like that. It's very flexible, and because it's flexible, you can apply certain OO rules, but not everything really works. And there were some very creative ways to kind of apply object-oriented principles to JavaScript. The support for object-oriented programming has improved over the years, but historically JavaScript is not great for object-oriented code. Then TypeScript was invented to help with object-oriented programming. It's not the only reason it exists. You can write procedural or functional code, the sort of style of code you've been writing up until now. You can use TypeScript with that, absolutely no problem. But it really does lend itself very nicely to object-oriented code. So, before the lesson, Mushtaq asked me kind of what is TypeScript, is it JavaScript, what's the difference? Well, technically it's known as a superset of JavaScript. So that's kind of the opposite of a subset. A subset is a smaller part of something. So if you had the numbers 1 to 10, a subset would be 2, 3 and 4. A superset would be the numbers 1 to 15. It encapsulates everything in the numbers 1 to 10 plus some more. So it is just JavaScript plus some features. So the really huge benefit of this, of the idea that it is just JavaScript plus some features, you can start writing TypeScript immediately, because all valid JavaScript code works as TypeScript. So that's why it's referred to as a superset. The difference is it's strongly typed, or you are encouraged to strongly type your variables. And I don't mean press very hard on your keyboard. I mean you assign a type, a data type, to a variable or an argument, and that generally can't change. So everywhere in your code where a variable is used, it always must be a number, for example, and if you try to use it as anything other than a number, TypeScript is going to step in and go, oh, did you really mean to do this? You're going to use a number where you should use a string, for example. It actually just compiles to JavaScript, because your browser can only run JavaScript. Therefore, TypeScript actually ends up just being JavaScript. So there's also additional features on top of strongly typed data. There are all sorts of things, and TypeScript, it's in the name, it is JavaScript but strongly typed, but actually because of its popularity they've added all sorts of features that are not necessarily related to the sort of data type features, if that makes sense. So, like, why would you use it? Why would you use TypeScript instead of just normal JavaScript, when ultimately it's going to be JavaScript running in your browser either way, because computers are good at catching errors. So if you're refactoring, which is a huge cause of bugs, every time you refactor, you change the way a function works, and the first time you run it, it's probably broken. Where with TypeScript, the computer is kind of going to, ahead of time, sort of try to run that function that you've just refactored, and it's going to go, oh no, actually you told me that you will always pass a string, but here you will be passing a number, so you better change that. So even before you get to the browser, TypeScript says, watch out, you've done something wrong. Object-oriented programming makes sense. That's a sort of reason to use OO code. It's based in the physical world, and TypeScript really helps with OO JavaScript. And for me, this is really the biggest reason why you should use TypeScript, because you can just start doing it immediately. And that's all I did. In my current job, we use TypeScript. We exclusively use TypeScript, but I didn't have to learn it. I just basically renamed a file JS, renamed it to TS, and VS Code, my code editor, every time I wrote some JavaScript that could be improved with some feature from TypeScript, VS Code says, by the way, you probably want to do this. So you kind of just learn as you go. You learn these features of TypeScript. It's really nice. Then there's stuff on top, but ultimately the first few steps on the sort of TypeScript journey, you just write some JavaScript and let VS Code tell you what you can do better. It's a really nice process to learn it. So here is some JavaScript that we are going to refactor. Right now, it is a function that takes a user and then says hello user. Okay, so looking at that, user is the sort of username, it's a string. And then looking here where we actually call the function, we can see that we are in fact passing a string. So we're going to get hello Sam back from this function call. And here, we're not just hard coding this string, we're going to get a user from our API. So get the user from the API, then we've got a user, and we pass it through to say hello. So this is the user that's just logged in, or it could be anything. But we're passing it through to say hello, and we want to see hello Sam, or hello AJ, or hello Mushtaq. In fact, we get hello square bracket object, capital O object, square bracket. I'm sure you've seen this before, and I think I've demonstrated this before. This is when you pass an object through to a interpolated string, a template literal, and it goes, okay, you've given me an object, I'm going to try and convert that to a string, and that's what it does. That's what a string that's what an object converted to a string looks like. That's because API get user actually gives us an object. So now we've refactored. We've now taken this JavaScript code and we've turned it into TypeScript. The only difference, forget about the comment, the only difference is this syntax. We're now saying this is a parameter called user and its type is a string. Therefore, we can pass it through to the template literal and it's going to display hello user. Now we have the same code down here. Say hello user. TypeScript goes, you can't use an object for that. You need to pass a string because this is always expecting a string. It knows wherever this is defined, it knows that that returns an object that represents a user. So we say hello user dots name, and then that is the string that is stored inside this object and gets passed through to the template literal up here. If we try to pass something that's undefined, which could well happen in JavaScript, we might get hello undefined. In TypeScript, it's not even going to allow that. If there is the possibility that this is undefined, if you have typed your functions, if you have declared your functions correctly with the correct types and everything, you should say perhaps that name might actually be undefined. So TypeScript is going to go, nah, this is going to be either a string or it's going to be undefined. Here you've said I'm only allowing a string, so you can't call it. So we need to create an interface. Now an interface is pretty much a kind of template for an object. So we have defined an interface called user, and it is an object that has a key of first name and the value is a string. Notice that we're not using commas. If we were using commas, it would be kind of like actually creating an object. But here we're using semicolons. These are individual lines that describe each key and the type of data being stored at that key. So every user object is going to have a first name and a last name, and they're both going to be strings. Now we've got this get user function. Here we see this colon. We're denoting that get user is a function, an arrow function that returns a user interface object. So here we are saying this variable has this type, and then it's equal to whatever the value is here. So in this case, the value is an arrow function that returns this object, and here we're saying that the variable is a function that accepts no arguments and returns a user object. So now we still have say hello, that hasn't changed, that accepts a string. Here we can say this user variable is going to be a user. It's a little bit like a class. It is going to be an object that implements the interface user. That's kind of the correct terminology, but I don't really like how that sounds. It is a user object. That's a bit more understandable. So this user is going to be a user object because this function we have declared is a function that returns a user object. So we get our user object, and then we can access the first name which we have defined in the interface, as a string, and therefore this function runs and TypeScript accepts it. Okay, so to get started with TypeScript, we need to install it. So TypeScript can be installed using npm, so we can install it globally, and it's relatively small actually. Actually maybe because I've already got it installed, so maybe that isn't representative, but I think it's surprisingly lightweight for the features that you get. To compile from TypeScript to JavaScript, you write the command in your console, in your terminal, tsc, and then a path to a TypeScript file, so .ts. tsc stands for TypeScript compiler, so we want to compile a TypeScript file into JavaScript, and I've got one here. Oh, let's delete that. Oh, spoilers, you've seen it. Okay, so console log, we're in a TS file, tsc index.ts. Great, because running scripts is disabled on this system. Ooh, that's, oh dear. Cannot be loaded because running scripts is disabled on this system. See about execution policies at, oh dear, this is my work computer. I must have done this lesson on my personal computer in the past. Okay, I'm gonna see what is at that link. Perhaps I can do it in command line. Okay. Hooray, sort of. Okay, so in that case, can we... Okay, great, that'll work. No PowerShell, tsc index.ts. Yes, that works. Okay. So hopefully you can see what that's done is it's taken this TS file and it's created an equivalent JS file. And let's look at the differences. They are identical. Because, remember, JavaScript, any JavaScript is valid TypeScript. We've just written some plain old JavaScript and it's compiled from TypeScript into JavaScript and it hasn't had to change anything. So now, is it just to the code editor next? Yes, it is. So now let's do that say hello function. So we've got say hello is a name, which is going to be a string, and we're just going to return hello with a comma, can't forget the comma, name, like that. Now let's run the TypeScript compiler again. So here we get a variable using var that is say hello it's equal to a function, a function declaration that takes a name and returns a string plus name. Ooh, I can't move that out of the way, but I don't think you can see it. Or maybe you can see it. Hello plus name plus exclamation mark. So it's taken our nice modern JavaScript that is valid TypeScript, although I've got some okay, that's going to be annoying. Well, don't ignore that JavaScript file. Ignore that. Okay, that's going to be annoying because it's looking at this file and saying you've already declared something called say hello in here. Never mind. So it's taken modern JavaScript that is valid TypeScript. In fact, this is now TypeScript because we have a type declaration, and it's converted that into old-fashioned JavaScript that can run in any browser, that can run in Internet Explorer 6. But it's actually not really done anything else. What you might have expected is if name, if type of name doesn't equal string, because throw error, because that's what we've denoted over here, wrong type. You might have expected to see that, but the compiled JavaScript that TypeScript creates doesn't have all of the type checking inside the code, because that would make the files that your users download absolutely massive. So it kind of runs your code and does it all beforehand, before it then just spits out the old-fashioned JavaScript that your users will use. So let's see what happens. Say hello, Sam. Say hello, blah blah blah. Say hello, Sam. Okay, fine. Say hello, 6. Found one error. Argument of type number is not assignable to parameter of type string, and VS Code has underlined this. Argument of type number is not assignable to parameter of type string. So it's been kind of nice to us and actually just compiled it anyway, but you can configure it so it doesn't do that. And I'll show you kind of how to configure everything a bit later on. But if you try to write some code that isn't following your own rules, then TypeScript is going to say, hey, there's something wrong with this. You're using a number when it should be a string. What we can do to get around that is actually use a single pipe. So where you have an if statement, if true or true, double pipe is or in these kind of comparison statements. It's a little bit similar in TypeScript where we are specifying the different types. Now say hello will accept a string or a number. So a single pipe allows us to specify multiple types, but we don't actually want a number. So you can do to string identifier or keyword cannot immediately follow a numeric literal. Okay, that's an interesting one. So we have to do that. So VS Code, if you didn't know, was made by Microsoft. Typescript was also made by Microsoft, and therefore the TypeScript support already built into VS Code is really great. You might already have sort of seen hints of this generally when you're writing JavaScript in VS Code, because it will come up with pretty useful errors or warnings that are related to this sort of thing, and that's because VS Code sometimes, I don't really know why or when, but sometimes does seem to just treat JavaScript as TypeScript. It kind of runs it as if it would be TypeScript, just so it can catch some stuff for you if you need it. Okay, so let's do some more stuff. Let's write an interface for a tweet. So we've got a user ID, which is going to be a number. We've got content, which is going to be a string. We've got time, which is going to be a date, probably. Date, time. I mean, it's actually going to be a number, but I reckon there's probably a sort of TypeScript type that is actually date, time, something like that. But time is going to be a number because when you run date.now, you get a number back. So now we're inside a TypeScript file. All of these built-in methods that the browser gives us, these kind of preview things, actually now you'll be able to read this a bit better. Okay, this is a function and it returns a number. So that is really, really useful. It it reduces the need for documentation. Documentation is a massive part of programming, and you will no doubt be writing documentation at some point in your careers. But with TypeScript, what I can't stand is, especially when you're writing TypeScript, with JavaScript it's understandable, but when you're writing TypeScript, what I often see is stuff like say hello, how does it go? Param, yeah, like that, no. Okay, param name, string, I don't know, I can't quite remember the syntax, and then return string. So this, I can't remember exactly the format, but this is the sort of thing that you will possibly see in lots and lots of JavaScript code. It is describing a function, and then it comes up here. It's kind of nice in that way. It comes up, so if we're in some other file and we're using say hello, we can hover over it and we can read about it. Say hello says hello, and then that says say hello says hello. But this, for me, is just a complete waste of time. If you have a function called say hello, you shouldn't need to say that say hello says hello. If you have a parameter called name that is being marked as a string in TypeScript, that doesn't tell us anything. And by default, TypeScript can look at what this function is returning and already kind of figure that out. So if we get rid of that, we can hover over, we can see that TypeScript's figured out that this variable is of the type a function that receives a parameter called name that is a string and returns a string. So you can you can specify the type of the function like this, but really I tend not to for functions, because the TypeScript compiler can figure out the value that's being returned anyway. Okay, so we've got a tweet there. Let me just check the slides because I can't quite remember what's next. No, let's stay in the editor for a little bit. Okay, so if we've got a function called get tweets, and maybe it takes a user ID, and this is what I'm saying. This is what I meant earlier about just writing JavaScript and VS Code telling you how to improve it. So we can do it with this one. Parameter name implicitly has an any type, so that is a type of any. That is basically just saying, okay, I just want to write plain old JavaScript where anything can be anything. I don't want to specify the types. I can't be bothered. That is, it's a necessary evil, but and you certainly will do it sometimes, but generally never do that. So what this can do, infer parameter types from usage, it can kind of guess the type of this parameter from how it's used in the function. So actually inside here it's possible to have a string or a number, and therefore it has VS Code has figured out that the type of that argument is going to be a string or a number. So that's what I meant earlier about just writing JavaScript and letting VS Code tell you how to improve it or how to convert it to TypeScript. So we're going to do that again. We've got our user ID. I don't know, we make some request to the server, fetch users user ID tweet then response.json, then tweets that's probably it, or maybe let's say tweet contents. So tweet contents, because this is some kind of inbuilt function, because what we get from a fetch request actually could be anything. This by default has a value of, as a type of any. But what we can do is say this is actually going to be an array of content and time, for example. So we can have an object that has content, which is a string, time, which is a number, and we chuck some square brackets after it to denote that that is an array of this thing. So an array of numbers would be like that, an array of strings would be like that, and you get the idea. An array of tweets would be that. Tweet contents, we're not actually getting an array of tweets back, but never mind. So we can now return tweet content for each, and here we're already seeing value is going to be an object that has key of content, key of time, an index is going to be number, the array. It's not very readable, but after a little while you can read this and really figure out what all the functions do without having to read any documentation. That's why TypeScript is so good. So for each tweet content, we're going to return, we're going to spread out the tweet content and plus that user ID, which is actually a tweet. Therefore, what we can say is as tweet. So I want you to take this object that has some kind of values in it and user ID and stuff, and I want you to treat it as a tweet. So now if we return get tweets, it's even telling us that we can convert it to an async function. So quick fix, convert to async function, quick fix, infer parameter types from value. Okay, that is actually just saying any, but let's say change that to number. Here, infer parameter type, tweet content. It's not actually going to be a tweet, but it sort of will be, so that's fine, that'll do. As tweet, now get tweets, that's an async function, so we've got to wait, or we can say get tweet. I don't know, you sort of get the idea. Then we call that and then we get our array of tweets and we can iterate over it. We'll do that later when we're building our sort of Twitter app. So most of this is just JavaScript that you know. It is just adding some handy features. Oh, let's compile it. Let's see if we get any errors. We don't get any errors, and we actually get a much bigger file down here. So let's have a look at what this has done. Underscore underscore assign equals this assign or function assign equals object assign or function blah 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 return assign apply. Okay, awaiter equals this and awaiter function the function adopt new promise generator. And now finally we have console log, we are in a TS file. So all of this stuff, this is what's called a polyfill. So because we're using features like async await that are not possible in Internet Explorer 6, for example, TypeScript knows that it's going to have to add this functionality into your code because the browser isn't supplying it for you. So it automatically adds the features that you need. So get tweets is this function. It's a function. It returns a waiter. So it returns the result of some other function call, and then there's a function here where we have a response and tweet content, and then generator, and then fetch, and then so it doesn't really look like our code, but this will work in old browsers, whereas this won't necessarily. So it's really, really powerful. And This is actually not really TypeScript. This is Babel or Webpack, and we'll look at that later on in the course. But the idea of taking modern code and changing it so it will work in any browser, that's not necessarily limited to TypeScript or object-oriented code at all. Okay, so that's just like a first little taste of TypeScript. Let's go through. First, do you have any questions on that? We're going to talk a little bit about object-oriented stuff again, and then we're going to build some Twitter stuff using TypeScript.
Just a quick question. I was just wondering, so for example, if in an HTML file, usually we have like a link to the JS file. Do we instead link to a TS file, or like or is that okay, or do we need to link a JS file?
That's a good question. So no, you would be linking to the JS file. So
Okay.
if we did have an index HTML here, script source, it would be index.js. So before before you commit, you would run TypeScript compiler index.ts. It would generate the JavaScript file, and then you push that generated JavaScript file, or something along those lines. Now, next, before we start building Twitter or to build our little Twitter project, I'm going to show you a sort of project setup using TypeScript. So actually, you don't have a script tag like this. That is kind of generated for you. So don't worry about that too much. And later on today, and then in the next module, you'll see how kind of modern pipelines are set up. So you're not really touching this HTML file very much.
Well, cheers.
No worries. Okay, so let's talk about object-oriented stuff again. Encapsulation, abstraction, polymorphism, and inheritance. And how does TypeScript help? Or just one or two examples of how TypeScript helps with these four principles of object-oriented code. Private and public methods and properties. We talked about this on Tuesday. Private and public, it is a really important part of object-oriented programming, but it's just not possible in plain old JavaScript. So in TypeScript, they have added the private and public keywords. So in this case, we've got a class called person. Their specific first and last names are actually private. They're only accessible within this block of code, but they are exposing a name that is actually a combination of the first name and the last name. So that's one example of how TypeScript features encourage sort of stronger object-oriented programming. Abstraction. Now there is an idea of abstract classes in TypeScript. So here we are denoting that a mammal is actually an abstract class. This essentially means that it's going to be a class that actually doesn't have any direct instances of mammal. It is only there to be extended or to be a parent class. Who's that? Dahe's joined. So by abstraction, we're talking about sort of taking things away, and that's what this abstract class does. We're sort of specifying a class to then be extended, and we can create a person that implements all of the stuff in the abstract mammal class. But actually, we can't just create a mammal. In the real world, there is no such thing as a mammal, but there are lots of things that are mammals, if that makes sense, like a jacuzzi and hot tub. A jacuzzi would extend hot tub because a jacuzzi is a hot tub, but not all hot tubs are jacuzzis. Yes, that makes sense to me. Polymorphism. Abstract classes also help here. So we can say that this variable is going to be a mammal, and in this case it's going to be a person, but we could do if some kind of type is P, then new person, otherwise new fox. Both of those are mammals, therefore they will both let's fox extends mammal. They both extend the abstract class of mammal, therefore they are both applicable here. So it's pretty much the same, there's no real change there, but abstract classes just extend that idea a little more. It's really marking a class as only there to be extended, and that's pretty useful sometimes. Inheritance, of course, that's pretty much all abstract classes are. So abstract classes are an example of something that really helps with writing nice, organized, object-oriented code. Now, writing nice, organized, object-oriented code is probably not going to happen for you guys for quite a long time. OO code is easy to mess up and kind of overcomplicate. So I think a lot of TypeScript features, they take a little bit of time for you to actually appreciate them, but I hope just something like this, I hope you can already see why that would be useful. Just saying that this can only be a string, and then somewhere in your console, before you even get to the browser, it says, nah, you're not allowed to do that. So that, for me, is the sort of selling point of TypeScript. It tells you that you're about to be an idiot before you realize that you're an idiot. It's really great. Okay, to the code editor. I think we're sort of going to not go to the code editor now, and we'll have a look at some more TypeScript features on the official website, and then we will build some of those Twitter features. Oh dear, I'm a bit tired today and my throat is starting to hurt. Never mind. Okay, so basic type, boolean, number, string. This is all normal. String, number, string. Array. We've got an array here. Now, you can write an array type like this as well. So number with square brackets, that is an array of numbers, or big A array, angle brackets, number, angle bracket. I personally much prefer this one. I think if you are going to start writing some TypeScript, if you're going to start a project using TypeScript, then just pick one. It doesn't really matter as long as you're consistent. It's very annoying if you're inconsistent, but ultimately the two are interchangeable. And I don't really like the fact that the two are interchangeable, but never mind, that's TypeScript's choice. A tuple. So I think I might have mentioned tuples in the past. So we are going to specify that let data is going to be a string and then a number, and data 0 is hello, data 1 is also hello. And we're already getting an error. Type string is not assignable to number. We're trying to specify that the second, or the first element in this array is going to be a string, hello, but we're not allowed to do that. So we can only have that as 4 or some other number. Let's run the TypeScript compiler again. Okay, I've still got that error. And let's see what we get down here. And there's actually nothing. It's just create a variable called data and then set the first element to hello, set the second element to 4. This idea of a tuple doesn't really exist in JavaScript. So that's all we can do. And actually I've sort of realized that this just won't work, because this, even though we're denoting that this is going to be a tuple where the first element is a string, the second element is a number, it actually never gets created as an array. But then it says type, the empty array is not assignable to type string number, source has 0 elements but target requires 2. So I don't know, I suppose you'd do something like that. Let's see what we get in here. I think it's just going to look pretty similar. Yeah. Okay, yeah, that's a little bit weird. That's a slightly strange example, but I mean I've certainly used tuples plenty in my time, and tuples aren't limited to 2. More data. You can have an object here. You can have a boolean here. You can have a function here. Type string number is not assignable to type blah 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 blah. So a tuple is known in other languages because there's 2 of them, but actually I can't remember what it's referred to as, a sort of varying number of elements but a fixed number of elements, like an n-pul or something like that. Okay, yeah. Aha, yeah, okay, an enum. Enum is pretty useful. So let's have show message and a type, and if type is 1, return hello, else if type is 2, return bye, and so on. That that's just really not very descriptive at all. If type is 1, what does that mean? If you're going over here, you're saying const type is 2, like what? And then you pass it through to show message type. That really is not very clear whatsoever. So we might have something like an object, message types, and hello is 1 and bye is 2. Therefore you'd have message types dot hello or bye, which is much more descriptive. Message types dot bye, and then that's more descriptive when you're away from all of this code. It's more descriptive inside this code, and this is a very common pattern. So storing your data in an object with descriptive names is a really common pattern that I definitely encourage. And an enum is a built-in TypeScript helper for that. So the syntax for this is we're declaring a new enum with the name message types, curly brackets, and then we just list all of the different things it could be: morning, evening, yell, I don't know what all sorts of messages could be. Error, always need an error message. And we access it in exactly the same way. Message types dot hello, message types dot bye. So these actually do end up being numbers. So it is actually set to 0. Bye is actually set to 1, morning set to 2. So again, we can have quick fix. Oh, that's annoying. Quick fix, infer parameter types from usage. So we're now saying show message must receive a parameter of a message type. So it's really nice. Now I'm curious to see what it generates. Don't save. Open to the side. Ooh, that's interesting. So we create a variable called message types. Then this is just a pretty weird way of creating an object. Yeah, it's just a weird way of creating an object. Basically what that's doing is just saying message types dot hello equals 0, message types dot bye equals 1. So what I had previously is exactly what it gets converted into, really. And then here, our JavaScript code actually ends up looking pretty similar. So message types is an object, dot hello is 0. So it's taken this really quite neat code where we've got a type of one of the message types into this slightly weird but very robust and smart JavaScript. So that's enums. By default, enums begin the numbering members starting at 0, so quite often you don't really want to include 0 because 0 is falsy, just in case you want to, I don't know, handle something that's undefined or whatever. Quite often you don't really want to start at 0, so you can start at 1 if you want to. Or you could set them yourself. I'm not entirely sure of the point of that. Okay, unknown. I would encourage you not to use that very much, but occasionally you'll need to. Again, same thing with any, so you can specify that something is going to be any, loosely typed any for, and then it becomes something else, or it's sort of defeats the point of using TypeScript. Void is a little like the opposite of any, the absence of having any type. Yeah, so void to me is more or less the same as undefined, but you can actually specify undefined and null as specific types. So this variable has a type of undefined, this variable has a type of null, and you can actually, there you go, not much else we can assign, but very occasionally they are useful. Never, okay, let's forget that because I've never used it. Object, yeah, object. So if you're kind of, you should tend not to use object. It's basically anything that has key value pairs, but that's really not very descriptive at all. You should create an interface to describe that object. You can kind of ignore that stuff. So interfaces. Yeah, here we've got an interface with a label that is a string. Optional properties, yeah, this is an interesting one. So by having a question mark after the name of the property, we can say square config. Let's have my tweet. So I don't know what is optional on a tweet. Oh, image URL. So a tweet may or may not have an image URL with it. So we're saying that it might be there, but it's not required for it to be a tweet. So if we now, my tweet is user ID, and in fact my tweet is going to be a tweet, so user ID is going to be 1, content. Now because I've just specified this variable as a tweet, it's kind of auto completing slightly differently. We have this little box here. This is kind of saying this is a property of the thing that you're currently creating. So it even helps writing your variables. Look, we've got property time is missing in type but required in type tweet. So we need time. And now we don't have any errors. It is a valid tweet, even without the image URL. We can auto-complete image URL. It has a question mark. HTTP image.jpg. So now it's still a valid tweet if we added something else like thumbnail URL. It's going to say type this object that has all of these things is not assignable to tweet. Object literal may only specify known properties, and thumbnail URL does not exist in type tweet. So if you try to add more than you should have in a tweet, it also throws an error. I mean, that's probably it for now. We're going to look at classes a little bit more, but I think that's it for now. So let's build Twitter. So we're going to look at the requirements. So log in, create a tweet, update avatar on click, leave a comment, like, retweet. Okay. So, oh, that's not what I wanted. rule. Aha. Okay, and then okay, that's going to start up. We now have that running at localhost 2000. Now, that's where we've just been working. This is where we are going to work and build Twitter. You can see we've got a whole bunch of extra files. I mentioned Webpack earlier. You can pretty much ignore it for now, but Webpack is very complicated and does lots of things at the same time. In this project, it's going to reload the page automatically. It's going to recompile the TypeScript automatically. It's going to create the HTML web page for us automatically. It's going to run all TypeScript files through the TypeScript compiler. We could compress all of the images. We can do all sorts of things with Webpack. You don't really need to worry about it now. We're going to go into more detail at the end of this module and kind of into next module. You should be familiar with package.json. We've got our dependencies, we've got start, we're going to run npm start to start it. Now this is a TypeScript config file. It's quite good to have all of these kind of explanations of what they do. Pretty much this is how I have it set up. So strict type checking, because what's the point of using TypeScript if you're not going to have strict type checking. Resolve JSON module, I've added this one because it doesn't really matter, but I find that useful. And then consistent casing in file names. That's a very annoying one, especially if you're using Windows and Mac and they treat file names differently. But generally most of these you can sort of ignore, and again, it's unlikely that you'll be putting together one of these files for quite a long time. You'll probably have seniors who will decide how they want to configure TypeScript for a particular project. But we're going to write our code in index.ts. We have an index.html file, and let's get rid of this. That was from previously. And notice, AJ, there's no script tag. So what we're now going to do, npm run, or just npm start. This is going to start our Webpack server. We've got a header, ts, and then we've got sss down here. So that's our header. If we look in elements, that's our div id root index ts. This is we found that root element and then we've just appended some text to it. But we do actually have a script tag. That's from a Chrome extension, so we can ignore that. This is a script tag. So Webpack is actually building a JavaScript file called bundle.js, and we can see that in somewhere, sources, this is the file that is generated by Webpack. It's going through the Typescript compiler, and this is the file that actually runs in your browser. It's not very readable at all, but it doesn't need to be readable to a human, it needs to be readable to a computer. So Webpack is creating this HTML file and injecting, which is referred to over here, inject true. So I want you to take this template HTML file and inject the JavaScript script tag into it. That's what that means. So that's what I meant about you don't really have script tags anymore. I mean, you do in the browser, but you won't be writing them very much. Okay, so now where were we? We are doing some Twitter. We're going to get some tweets. We're going to leave a comment on a tweet and like and retweet. Maybe we'll do something like that. Okay, it's 7:24, so probably can't do all of that. I'm going to create api.ts. This is going to be just a file that has a bunch of functions in it. We're going to have get tweets and get tweets. Can't really declare block scope. Why? What? Where is that? Well, oh, did I do it in here? Yes, I did. Okay. Get all tweets. Great. So we're going to have an API URL, which is this this URL, actually API endpoint, is going to be just localhost 3000, then tweets URL is going to be API endpoint / tweets, then get all tweets is going to return fetch tweets URL It's already telling us we can convert it to an async function, so let's do that, why not? We then want to export an API object get all tweets. I don't think you've come across export and import syntax yet. Again, don't worry about it, we'll go into it in much more detail in the next module, but it's a little bit like require in like module.exports and require in Node. So over here, API, we're going to import API from API, API.getAllTweets, then tweets is going to be an array of tweets. Tweet is going to be defined in an interfaces file, and I've already defined one over here, but I've realized actually it looks quite different, so oh no, it looks fairly similar. So in interfaces we're going to have ID is a number, user ID is a number, tweet ID. What's tweet ID? Oh, is that in comments? Right, probably. Yes. So content, date, retweets and likes. That's going to be a number. That's going to be a number. Content is a string, and date is actually also a string, not a number in this case. Okay, so we've got our tweet interface. We can import it from our interfaces file. Now we can have display tweets, passes tweets, define display tweets, and we're going to say tweet is going to be an array of those tweet interfaces, those objects that have these specified key value pair types. Tweet.forEach tweet. We can then create a class for a tweet. So let's have a tweet box, something like that. It's going to display a tweet inside a box. So we have a class of a tweet box, and it's going to take a tweet as an argument in the constructor, and it's going to be private. We're going to access a tweet on the tweet box, but we're getting an error. Tweet is declared, but its value is never read. So Typescript doesn't like it if you create a bunch of variables and you never actually use them. So it won't even allow you to do that, or depending on the configuration, it won't allow you to do that. So there's another error as well. Property tweet has no initializer and is not definitely assigned in the constructor. So we can show initializing a bit more easily like this. Let's say, I don't know, age is number, and we've got the same error, but we can initialize that as 10. So this gets initialized, and this .age is always going to be 10. Age is declared but is never read. That's also coming up, but it's more like a warning. Depending on how you've set up your TypeScript configuration, it might allow you to have that anyway. This, we don't actually have like a tweet to set to this tweet out here. Therefore, we're going to say this .tweet equals tweet. So that's what the error was referring to. You've declared a property with a type of tweet, and it's not being set to any value. It's not being initialized, and it's not being set to a value inside the constructor. That's what that error was telling us. Now, what about name string? What if actually we may not have a name? So, or undefined. Now that error's gone away. We're not initializing it, we're not setting it in the constructor, but we are saying that actually it's possible that this name is going to actually be undefined. We might not have a string there. So when we access it later on, this .name.split, if we want to split it with, it's doing it for me. I want to write it without that question mark. We want to split by, I don't know, space. It's saying object possibly undefined. This object might actually be undefined. You're trying to do something with a string, but it could be a string or undefined. Therefore, there is a feature actually in very modern JavaScript, but really it's not implemented into browsers yet. We can have a question mark. What you would do previously, if this .name, like if there is something there, if it's not undefined, then go ahead and call split. And you can see the error's gone away. So TypeScript is reading this and it's going, okay, right, I see you're already checking that something's there before you're trying to call split on it. But this is really annoying. And what if you had this .name, .something else, .something else, .something else, and it would get very big. Therefore, we have, I can't remember what it's called. It's called the nullish operator, something like that. We can say, like, if something's there, then go ahead and do this, but otherwise, like, just don't crash. Just let, like, possibly something's there or possibly it isn't. So that's how we deal with undefined things. So we've got our tweet up here, we've got our tweet. We can then create element, and div is document.create element div. First name is tweet box. This.tweet.content, so it's already coming up. I don't know. Let's this.tweet. And then it's already showing me my possible options because it knows that this .tweet is a tweet, and it knows that a tweet is an interface that only has these values on it. So it's really nice. It makes writing code much easier. So let's say the date. Let's return a div. Now we can kind of hover over it. It's already telling us that it is a function that returns HTML div element. Over inside here, app element.append. Oh no, so we want to create a tweet first. Tweet instance. We want an instance of the class tweetbox. New tweetbox. We pass it the tweet, and it knows that it's a tweet because tweets is an array of tweets, and it knows that for each gives us each element. So we can pass through the tweet, which is a tweet interface, through to tweet box, tweet instance, then tweet instance dot create element. We can call create element. That should, there we go. It's all doing it automatically. If we look in this terminal, app element dot append, let's say HTML div element. Here we've already got an error. So yes, it's got an error in this file. Actually, I've got a better way to demonstrate this, but anyway, it's not assignable to, okay, let's just forget about that. Yeah, I've got a good way to demonstrate this. So I'm going to change this function to receive some kind of number and it's going to be a number, and it's going to be plus, I don't know, number dot to string. Okay, that looks good to me. Number, there's no errors in this file, but I've got an error down here. Expected 1 argument but got 0. I can command or control click on this. It takes me directly to where I'm calling this function getAllTweets. Expected 1 arguments but got 0. I'm not passing anything through. An argument for number was not provided. So now I can go through and update everywhere that I'm calling the function getAllTweets to adhere to my updated version of getAllTweets. That is so useful, honestly. Like, the number of times I've refactored a function, I will have to do some sort of Control F, find everywhere in a project, look at everywhere that function is used and make sure that it's following the rules. But with TypeScript, I don't care about that. I just do it, save the file, TypeScript goes, oh, you're using it in these 10 different places. It's so useful. It's an absolute lifesaver. Okay. So what have I done? I've done something wrong. That I think is because this URL now doesn't actually work. Okay, great. Tweet instance create element. Okay. So what if create element actually we wanted that to be private and we wanted a public function called render, which, okay, right now just calls return this dot create element, but maybe it does a whole bunch of stuff to it as well. We have specified that this function is private, specified that this function is public, therefore the TypeScript compiler is saying you're trying to access a private property here, create element. So I'm going to change that to render, and now it's updated automatically and it's compiled it automatically and the page has reloaded. So maybe we'd want to do something like equals create element, return element, but in the meantime element.append let's do something like this dot likes or L and this dot retweets L. So I'm trying to access some things that don't yet exist. So I'm going to write some getters, some private getters. Likes L. This is how we define a getter. A get accessor must return a value. So there's no point having a getter that doesn't return anything. So what we can return is, I don't know, some kind of button. Return button, but button.inner text is going to be like this dot tweet dot likes, and we're going to do the same for retweets. So now they all have their own little getters to create buttons for liking and retweeting with their own data, and it's all kept inside this one file that deals with a tweet box. We can add event handlers to these buttons to increase the likes. So we could do that. I suppose let's just do it down here. Button dot add event listener, click this dot tweet dot likes plus plus. This one's going to be retweets plus plus. Now, sadly, it doesn't just automatically update it. So we will have to call render again, but render this create element render, re-render. How could we do this? Let's have element, this dot element, and then quick fix declare property element, this dot element, and so what that's done, that's gone up here and created element. Property element has no initializer and is not definitely assigned in the constructor. Private element. So in the constructor we can say this dot element equals this dot render or create element. So that creates the element. When we call render, we can do it again, or we can have something like this dot element or create element. So when we call render, let's do it like this. This dot element append, and then this dot render, and then now we've said increase the likes, increase the retweets. I think we'll just be able to call this dot render again, and because we've stored the element somewhere. In fact, we don't need that line. That's a stupid line. Oh yeah, it's creating everything every single time. So let's clear it and then create it all again, and now we have buttons that call render, they create those elements, they update the values, then you just add in the fetch requests and send the data back to the server, and you're done. So that's all self-contained within this tweetbox class, and in your index you're just saying, okay, I've got an array of tweets and now I'll just create 10 or however many tweet boxes. So that is how. On Tuesday we were doing kind of games that were not very web DOM HTML element stuff. It was quite different, but here I'm now demonstrating that you can write object-oriented code, JavaScript, but actually write TypeScript to build websites with all your traditional DOM elements and event listeners and all of that jazz. Right, 7:47. So 10 minutes. What functionality should I add to this? What should I go over? I want you to tell me something to do. Dahe, you missed the start. Is there anything that you would like to know that confused you? Is anyone there?
Yeah, okay, sorry, just thinking though.
AJ's there, okay.
Yeah, I mean, I was just thinking.
Okay, so I'll go over this again. Dan asked for this on Tuesday, and he said it was useful. So I think I'll just do the same thing. I'll kind of describe all of this.
I think Dahi's just asking.
Dahi's asked something. In the beginning, do you mean Dahi? Can you show me how you TypeScript in the beginning? So we started off with a TypeScript file, index.ts, and we're writing stuff that looks pretty much just like JavaScript. So console log, we're in a TS file, const say hello is name is a string, arrow function say hello Sam. Then we installed TypeScript on our computer. We went into example and we ran the TypeScript compiler by running tsc index.ts. That reads all of this code, it converts it into JavaScript and makes sure that you are following all of your own rules. So if I uncomment this one and run it again, it says argument of type number. We're trying to pass a number through to a function that should be receiving a string. So that's the sort of most basic use of TypeScript. It is just to convert from a TypeScript file to a JavaScript file, and just to kind of double check your JavaScript. So you just have to add these to your existing JavaScript and it will already help you. I think it will already help you a lot. So that's the sort of most basic version of TypeScript. Then we talk about other features like interfaces that are extensions of TypeScript and JavaScript. It's kind of a pattern for an object. So we now have an array of tweets from our server, and each tweet object looks like this. Here we're defining a tweet. We're saying this variable is a tweet and it's this object, therefore it only has these properties. Same thing with tuples, with enums. It's a really nice way to kind of organize your data like this. That I think I probably would have shown you something like that before, to have an object that stores your data and makes it very readable. But an enum is built into TypeScript and really helps you. But ultimately, it all goes back to just being JavaScript with some features. So that's why I would encourage you to at least try it out, because you don't have to learn anything. You can just start from nothing, compile your TypeScript into JavaScript and see what kind of errors you might come across. Okay, so inside here we've got our app element on our page. This might be null because if we don't find an element with this query, it's going to return null. Therefore, we can use this question mark to say, let's only try and do this if there is something there. So we append SSS to that. We don't really need to do that anymore. We've got our display tweets function. We have get all tweets. That is defined in our API file. After we've got all those tweets, we have an array of tweets that we pass through to display tweets, which is expecting an array of tweets. Iterate over that. We don't have to specify that it's a tweet interface here, because we already know that this is an array of tweets. Therefore, we don't really need to specify. Typescript already does that implicitly. So now we can pass it through to our class tweetbox that we've defined over here. So there's quite a lot of stuff in tweetbox. We can look at the outline down here. The class tweetbox has a property of age, create element, and name, and render, and likes L, and retweets L, and tweet. It's got a method of constructor, which is called by default when we call new. So we're passing the tweet through. We're assigning that tweet to our private property up here. We don't want age. We don't actually want name either. It just gets confusing. And I've got an error. Great. So age and name, I was just demonstrating something. I've just deleted them, and now we've got an error in our console, and it's saying property name does not exist. We've removed that. Therefore, TypeScript goes, actually, you're trying to access something. Even if it's possibly undefined, I'm not going to allow you to do that. So that is another demonstration of where TypeScript's nice. We've got a private function called create element. We've got a public function called render, which is what gets called in here. Render accesses this.tweet, this.likes L, and retweets L, which are getters. It's basically functions, but you don't have to use any brackets. It's pretty much what a getter is. So we run this code, we create a button, all of that. We call this.render, we increase the number of likes on this.tweet. Same for retweets L, and they're private, so we can't access them outside. We can't access them from this code. We can only access render, and I guess that's it for the tweetbox class. And we don't have to look at the API class. That's not quite as interesting. One last tip. So you'll see this sort of thing very, very often. So we've got tweet, and then you've got, I don't know, size is a number, and then you've got width is another number, and then you've got Twitter profile URL is a string, and you actually want those to be properties of this class. So you have this dot size is size, and this dot width is width, and so on. You have the same for Twitter profile URL. So you'll see that a lot. I'm going to pass in 4 different properties and then kind of immediately set them to properties that I've declared on this class. But this is very repetitive. Tweet, 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 size, size, size. So, and actually we've got it up here. So tweet, 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 tweet. Very repetitive. So what we can do, we can get rid of that declaration, then suddenly TypeScript gives us loads of errors. We can get rid of that assignment, and in fact all of these, and just by putting the private keyword in front of these parameters in the constructor, it's doing all of that for us. It's automatically setting up this .tweet with the value that it receives in that constructor. That is a really nice feature of TypeScript that just makes the code so much more readable. It's really, honestly, that is such a nice improvement. I find classes in my colleagues' code all the time, nearly every day, where they're doing this, and it drives me mad. And almost every day, I would say, I do this refactoring. I change it to look like this because it's just so much neater. So that is the last little TypeScript tip, just to make your code much neater. And I think that's it, unless anyone else has any questions. A little bit about interface. So an interface is a pattern for an object. So when we are defining a type to something, that is saying that this object is going to have all of these types of properties. We can see we're getting an error because we're missing ID, user ID, likes, retweets. We're missing loads of stuff. We're setting it to an empty object. We're going to say blah 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 is stuff, and it's saying no, that you're not allowed that because you've told me that this object is going to look like one of these. It's a little bit like a class, it's a little bit like an instance of a class, but it's just a bunch of key value pairs that stores data, and it looks like that. So that's your lot. Object-oriented code is